Broadcast is now starting. All attendees are in listen-only mode.
Okay, well, welcome everyone to this meeting of the Virtual IMS User Group. Thank you for joining us. I'm Trevor Eddles. I'm CEO of iTechEd. We're a mainframe consultancy, analysis and technical authoring organisation. We're the people responsible for the content on the Virtual IMS website, and we produce the newsletters. And if you've got colleagues who work on CICS, we also look after the Virtual Kicks user group. Right, first of all then, I'd like to run through the agenda for this meeting. And as usual, most of the meeting will be taken up with a presentation. And today our guest presenter is David Mierowsky. He's Managing Director of Fundy Software. And his talk is called A Smarter Way to Manage and Configure Your IMS Systems. And a copy of the slides from this presentation will be on our website later today. And if you missed any of our previous meetings, you can download copies of the presentations for those from our website, and a lot of them you can listen again to. And the links for that is on the resources page. So that's fundy.com/virtualims resources.htm. Following David's presentation and any questions you have for him, we'll move on to the latest IMS news and latest IMS related articles. Feedback requests is there to remind me to ask you for your feedback about this virtual meeting, and then I'll give you the dates and times for the next couple of virtual meetings. So that's the plan. I'm anticipating that this meeting will last about 50 minutes, something like that. So, as I just said, today's presentation is from David Mierowsky. David is Managing Director of Fundy Software and also the architect of the IMS Configuration Manager. David's been working with IMS in various roles since 1975. So, David, I'd like to thank you very much for being with us today. And what I'm going to do now is pass control of the meeting over to you. So let me just do that now. There you go. You should have a message on your screen.
Okay.
Yep.
All right. Hello, everybody. It's David Mierowsky here from Fundy Software. I'm going to be presenting today a smarter way to manage and configure your IMS systems. I'm actually talking from St. Louis in the US, where I'm at Share, and we have some big celebrations here at the end of the week to cover the IMS 50 anniversary. So it's quite exciting. We have a whole lot of old-timer IBMers coming in. It's going to be an interesting day. Okay, on to the presentation. So, okay, good. So I guess one of the things about managing IMS systems today is there's just a lot of complexity in the configuration of the IMS systems. There are a lot of different startup parameters. These parameters are stored in a variety of PROCloud members. There are JCL overrides for those parameters. In addition to that, the actual number of address spaces that you have to manage with your IMS topology is increasing all the time. So we have shared queues at address spaces. We have CSL, OMs, RMs, IMS Connect, etc., and that's it just seems to be increasing, and it's important to understand the relationships between them, and each of those systems itself has configuration parameters that need to be managed. And in addition to that, the number of IMS systems that you actually have to deal with is increasing over time as well. And as companies get larger and new applications come on, companies merge or take each other over, the number of IMS systems in your site might become more and more. And then every time IMS is upgraded, new versions, new releases come along, new functionality comes in, there are new parameters to control those new releases and that new functionality. So one of the problems is actually understanding what you have. What is there actually in my IMS system? How many IMS systems are there? What are the plexes? What are the connections? Which IMS Connect systems do I have, and which IMS systems do they connect to, etc. And then you have to get into the issue of actually managing the members for the Proc Lib. So if you look at a typical Proc Lib data set, you'll see hundreds of members. There are all sorts of things in there. Not some of them are actual JCL procedures, and some of them are startup parameters. Just the way IMS has always worked, and put all of those things into the same data set. And you need to know which are the actual active members for each IMS system. IBM does provide a syntax checker for the members. It's not complete, and yeah, it can be a little problematic to use with some of the parameter members. So that's one of the issues we try to address in the product I'm talking about today, the IMS Configuration Manager. And then, as you change parameters, you need a method of actually creating an audit trail of those changes and being able to go back to previous versions of a member if you need to. And then with the number of systems that you might have, they may be spread across different MVS plexes across different physical locations. It becomes quite problematic to actually compare and see and find differences in your configurations that might be causing a problem. So I'm going to cover all of those issues and how we've gone about addressing them, and how we can make it easier to manage these this growing number of IMS systems that we might have. So one of the things about Proc Lib members is they don't get changed all that often, so it's not that easy to come and say, okay, I need to change a parameter, and you have to figure out, well, where is the parameter. There are over 35 different Proc Lib members as of IMS version 15. We're getting up to close to 1,000 different parameters and subparameters, and every new release of IMS that comes along, and IMS 15 was no different, introduces some new sets of parameters and changes parameters. And of course, there's all sorts of dependencies between the parameters as well. And yeah, unless we understand them and actually are aware of all the new parameters, we may not set them correctly, and then we may have performance or other types of issues. Okay. So let me just talk about Autodiscovery and how it came about. So we were working with a customer some years ago. They had 4 data centers, 7 MVS plexes, 85 IMS systems, some in IMS plexes, some not, and they wanted a way of comparing and having a look at all their Proc Lib members and their startup parameters across all of their systems. And we said, well, that's simple. We can use the IMS Configuration Manager to do that. All you have to do is go into the ISPF dialog and define all your IMS systems and all your Proc Libs. And they said, well, that's ridiculous. We've got 85 systems. Like, things keep changing. It's gonna take us longer to define them than it is to actually do the job manually. So that caused us to have a think about Autodiscovery, saying, well, we actually need to automatically discover all these systems for customers. So we set out building quite an extensive Autodiscovery capability. And Autodiscovery is nothing new. There's been ways of discovering IMS systems for quite some time. There's a sort of traditional method of scanning MVS control blocks on MVS system, finding the IMS address spaces, and then peeking in the address spaces and seeing and getting the information you needed. We took a different approach, particularly for plexes, and we have a look at the XCF groups that are running, and for each XCF group, we figure out is this an IMSplex XCF group? is it a shared queues XCF group, or is it an IMS Connect XCF group? And then we look at the XCF members and fan out from there. We'll actually use, if it's an IMSplex, we'll use the CSL and issue type 2 commands to discover the members in the system. And then we'll analyze all that information, put that all together, and then we'll actually have a look. Rather than actually peeking inside an address spaces, we look at the log of the running job. So just basically looking at using JES2, JES3 capabilities. Have a look at the output from the jobs while they're running, and from there we can figure out what the different data sets and proc labs, etc. are, just by looking at the JCL that is being used to run that job. So we never run any code inside any IMS address space. It all sits external. There's no need to add step labs or anything into your IMS system for our auto discovery to work, which kind of would be self-defeating if you took that approach. Okay, and this shows you some sort of what you might see in the ISPF dialog after you'd run auto discovery. You might see. I'll just use my little pointer over here. The different systems that you have, what type of system it is, what plex it's in, and what version and release it's running. Just a bit of clarification on the version and releases here. One of the unfortunate things that IMS did is, as they introduced each new component into IMS, that started off at version 1.1. So you see differing versions for ODVM, for OM, SCI, etc. And basically those releases incremented each time the IMS version incremented, but obviously they're not in step any longer. From there, you can go down and have a look at each system. I'll just highlight that again. And you can see all the details for a particular system, what plex it's in, what the DFS PV member is, what JCL overrides there are, and what proc labs are in use for that system. We can select a particular IMS system and then have a look. Well, these are all the actual active members. So we've taken the DFS PB member, we've analysed it, we've had a look at what are all the other members that are defined in the DFS PB member. So what library it's in, and all the ISPF statistics. Those libraries 1 and 2 correspond to these libraries down here. So now when you come in to look at the different proc lab members for each IMS system, you don't have to know the proc lab, you just have to know the IMS system, and it will take you straight to there. And when you go into the member, it will then show you the name of the data set and the member name, obviously. And when we're inside editing a member, this is standard ISPF edit. It looks exactly like IMS edit. We don't modify the members at all. We don't scramble them. We leave the comments as they are, and you just use normal ISPF edit to actually make the changes. You'll see at the top, and I'll speak about this in some more detail further on, just some additional extensions we've added into ISPF edit to make editing and changing these configuration members a lot easier. So let's have a quick look at auto discovery, and I won't spend too long on this. So let me just add. We have a what we call a definitions repository. It's a small VSAM data set in which we store all the definitions that we discover. So all of the plexes, IMS systems, other IMS address spaces, IMS connects. All of that information that we find gets stored in our definitions repository. I guess it was a little unfortunate that we chose that name, and it's not the same as the IMS repository. It's completely different. We did have a look on the last release that we did of changing that name, but it's embedded in all the documentation and all of the code, and just proved to be an impossible task. So we're stuck with definitions repository. We just remember that's not the same as the IMS repository. So there are two ways of running Autodiscovery. You can run just a standard batch job that will do all of the discovering of the IMS systems. We also have a server address space, which again, some unfortunate naming terminology. The name IBM allocated to us was the Common Service Library. The initials are CSL, but that's not the same as IMS CSL. It is different. So we have a fairly lightweight server that you run on each Plex. So there's no need to run it on every LPAR. It just needs to run one instance per Plex. And when that server starts up, it can run Autodiscovery as part of the server startup. The bash job can be run, or the server startup can be run at any time, and it'll incrementally add systems as it discovers them to the repository. Autodiscovery never deletes any systems, because if a system is down when we run Autodiscovery, we don't take that as a sign that it needs to be deleted, because it just might be down for legitimate reasons. Deleting systems is a manual effort through the ISPF dialog. Okay, so Autodiscovery itself can run in Plex mode, and you can run it on a ISPlex and discover all the IMSplexes on that ISPlex, or you can limit it to a specific Plex. So if you've made a change to an IMSplex, you can just run Autodiscovery for that Plex. What we found in practice, it runs fairly quickly, so running it for all Plexes is not a lot more expensive than running it for a single Plex. We also have the capability of discovering IMS systems that are not in a Plex at all. So if you've got standalone IMS systems, we use the more traditional method of scanning the MVS control blocks and finding the IMS address spaces. And once we found the address spaces, then we use the same sort of JES2, JES3 techniques for finding the. Excuse me, I'm sorry. I'm still struggling with the time difference a little, so I'm a little sleepy. So we can do LPAR-based discovery to discover those standalone systems and add them to the repository as well. Okay, and that's just what a discovery job might look like. So it's just the JCL that's generated by the previous panel that will run to do the discovery. And this is what the output from a discovery might look like. So we're running discovery. We've discovered an IMSplex. There's an ODBM job, XCF group that it's in, the startup parameters, any step lib, the res lib, the proc lib that it's using, etc., etc. We've discovered another Plex, but there's no CSL active, so we can't do further discovery on that Plex. So there might be a reason why that is, but you can then bring up that CSL layer and or in fact that whole IMSplex might be down. In this case, the XCF definitions are still there, but if the system's not up, we can't do any discovery, obviously. We found a CQS system over here. Having a look at the CQS system, and we found in that CQS system there's another IMS subsystem that's running on a different LPAR, and it says, okay, we actually need to run the LPAR-based discovery on that system to discover all the details of that other IMS system. Found all the IMS Connect jobs, going through the IMS Connect XCF groups. Found an IMS Connect, the startup palms, libraries, the proc lib, etc. And then we're looking to say, well, what do we already have in the repository? And then start an update phase. I'll just drop that pointer. And then we can have a look and see, okay, well, we've discovered a number of different components. We've added some new ones, we've updated some existing ones, and we've detected some errors. And finally, at the end, I'm sorry, that we've listed all the IMSplexes that were actually down at the time that we were unable to discover, and that's the end of the discovery process. Okay, so let me just talk a little bit about the two different interfaces that we have. We have an ISPF dialog and we have an Eclipse-based GUI interface. The purpose of the ISPF dialog is to edit and maintain your IMS systems and your IMS ProcLab members. And the main purpose of the GUI is to look at your different ProcLab members, as well as your IMS resources, your transactions, your databases, etc., in a graphical form, and to be able to look at different definitions across multiple systems from a single point, and be able to do analysis on those definitions and compare them. And we'll talk about both of those interfaces separately now. So, editing parameters. So there's a couple of different ways of editing parameters. And going from the primary option menu, you can have a look at all of the parameter members for a particular plex. P-line command against the plex will show you all of the systems in the plex and all of the members within those systems. Coming in from a system view, you can go I'm just interested in this one particular system, and just see all the members for that system. Or we can go against the whole ProcLab data set and say, I just want to edit against this ProcLab data set, regardless of the IMS systems that they are. As I said, when we get into edit, it is a standard ISPF edit. We've added a new edit command called check, which will actually do a syntax check of the member. We've provided ISPF models. For those of you that have used model before, model is a built-in facility inside ISPF edit, and you can model JCL and Rex and all sorts of things to get sort of sample lines into your member that show you how to code the member, what the syntax is. And then we've extended the help capabilities inside edit as well, and we'll see a bit of that. In addition to that, every time you update a member using config manager, we will store the previous version of that member in the definitions repository, and then we can have a look at the history of the changes and revert to a previous member if things go wrong. Okay, so I'm now selecting option 1, which is plexes, and I'll get a list of plexes. I'll use the p-line command against plex dp, and come up with a list of the systems inside that plex. So we have an IMS system IDDP. Those are all the ProcLab members for that system. An IMS Connect system, ICM IC02, OM, RM, SCI, etc., with all of their members. So one of the things that we've also done inside the product is to create metadata for each parameter that IMS has. So we've had a look at the parameter, see what the parameter pertains to, and create a whole lot of keywords to go with that parameter. And you actually use those parameters then to search for. Sorry, use that metadata to search for the particular ProcLab members that might be applicable. So if you want to do something security related, you might say search security or search RACF, and all of the security related parameters will come up. In this particular example, we've done a search on ODBM. Here we can see there's an IMS Connect system as well as an ODBM system. And those are the ProcLab members that have the ODBM related parameters in. In the IMS Connect instance, We can see the DRDA port, OD access, etc. have 3 dots after it. That means that that parameter is not actually coded in the member, but needs to be added. We can see on the IMSplex that actually does have some parameters. That means that line is actually present in the proc line member. And you can use the standard sort of ISPF / command to see what you can do. You can either edit the parameter, or you can show the parameter help from that point. And we've put I guess quite a bit of work into these these metadata keywords. So if you're implementing the IMS catalog, for example, you can just do a search on the word catalog. Anything related to the IMS catalog will come up, and you can then go and change those parameters, set those parameters accordingly. If you're using the IMS cloning tool to create copies of IMS systems, you can do a search on cloning, and it will show you all the parameters that you need to change after you've cloned a system. We've also put in some keywords like new in v15, which we can see down there, and that will show you all of the parameters that are new in IMS version 15. We've also put a change in version 15 that'll show you all the parameters that are changed in version 15. There's also a v15 keyword that will show you everything that's new or changed in v15. And let's say you're upgrading from version 13 to version 15, you could put in v14, v15, and it'll show you all the parameters that are new or changed in IMS versions 14 and 15. So putting multiple search parameters there actually joins those together and gives you multiple parameters coming up for both of those keywords. Okay, so just now putting a little an H next to the particular parameter. So I say, what does this parameter actually mean? And up comes the help for that particular parameter. We can put edit next to the parameter as well, and you'll see we've come into the edit. As I said, it is standard ISPF edit with extensions, and we'll use one of those extensions, some of those extensions in a minute, just to see how those work. So we've used the model command. So we're going to do a model. We want to put our model line after this bottom line, and when we do that, we come up with a list of parameters for that IMS system. We can see there's a parameter log opt over here that has a little asterisk next to it. That means that particular parameter does not apply to the version of IMS release the version of IMS that we're currently working with. So it might be for a future release or a previous release. You can then select any number of parameters on that screen, and we'll actually insert model lines into your member, showing you the syntax and giving you some notes as well. So we can see down the bottom here, we've added in an ODBM name parameter with some underscores showing you where to put the value, and we've put a note line into ISPF edit showing what that parameter actually means. So we're now going to fill that in, and we've put in a value of this name is too long, and then up at the top we've used the check command, and that will do a syntax check of the member. You can see we've inserted a line here of dots with little pluses, and those pluses show us where the actual error is, and then some error messages just below it. So we said, okay, we have a duplicate parameter ODBM name, as well as that the value of ODBM name is too long. So we can see quite quickly, quite easily what the errors are, correct them, do check again until we have a member that has no errors left. A slightly more complex model. So we've done a model OD access in this case. So that brings us the whole OD access with all its subparameters and a description of each subparameter. It gives us what it actually is and the allowable values that that there are. We also see default values in the notes, and the default values have actually been inserted into the into the parameters themselves. So that's default values being inserted, and you can actually leave them in there or change them or do whatever you want to from that point. Okay, so now we look at a slightly more complex validation. This is an IMS Connect configuration member. So in your IMS Connect configuration member, you define what ports you're using for what purpose. Obviously, you can't define the same port for two different purposes. And then there's also a maximum of 50 ports allowed for an IMS Connect system. And in this example, we've used port 101 for SSL port, for port and for port ID. And we just see an error message coming up, again indicating which column on the plus, and then the actual text of the message saying that port has already been defined in line 3, column 9. So we know exactly where the incorrect definition is, and we can correct it. And then we can see down the end of the list of ports where we've gone over the 50. Some error message saying, okay, we've exceeded the maximum of 50. So it's just an example of some of the more extensive error checking that we do when we do the check command. Using help in a member. So anytime you're editing a member, you can put the cursor underneath underneath a parameter. Press PF1. And you will get help for that parameter. The help that you see is actually takes the form of an ISPF tutorial screen, and if it has subparameters, you can see all of the subparameters, and you can use the tutorial capabilities, putting the cursor on the parameter, and then branching off to that parameter and getting help for it. So you can see you can actually add a parameter. You can get a model of the syntax. You can code your values, you can run check, you can get help on what the actual parameter values are and what the parameter means, all without leaving the product or having to look at any manual. Okay, so let's have a quick look at viewing the active parameters again. So we've gone here through our option 2, looking at the different systems. We select a particular IMS system with the P-line command, and that will bring us up a list of the different members for that system. So again, we've gone into the PB member, and we've found all of the other members that are referenced by it. There are a couple of other members that have references to other members, and we'll expand those as well. We can see there's a couple of places where we don't have a suffix, we just have underscores. That means that particular member type is not used by the IMS system. We put it there as a placeholder in case you want to add it. And you have a number of line commands you can use: edit the member, view, delete, or have a look at the history, and we'll look at that in a bit as well. Okay, so here we're actually looking at the history of a member. So this is a DFS PB member, so the current member up at the top, when it was changed, and then all of the previous versions underneath that. So you can see a history there of the different members, who did the change, what date and time the change was made. Obviously, if you're making the changes outside of Config Manager and just using ISPF Edit or IB Copy or whatever, you don't see that. You won't see that in the log. Okay, and that brings us to the end of the ISPF dialog and the editing and maintaining of the PROC-Lib members. We're now going to have a look at what we call enterprise-wide management of IMS systems, and this is using our Eclipse plugin. So I should add that our Eclipse plugin is downloadable from the ZOS Explorer site. Just to give everybody who may not be familiar with ZOS Explorer, the ZOS Explorer download site is a place where you can download the Eclipse shell plus the ZOS Explorer. What IBM have done is done a consolidation of all the different Eclipse shells that there are. So the Rational Explorer and the Kix Explorer, all of those have come together as the ZOS Explorer. And there are a number of raw capabilities inside the ZOS that come with the ZOS Explorer that let you do things like create data sets, edit data sets, submit jobs, and have a look at the output of running jobs. So a lot of the things you might typically do from a TSO ISPF green screen, you can actually do from the ZOS Explorer Eclipse GUI. And then all of the different products that are supported by the ZOS Explorer are on that download site. So you'll see, obviously, IMS Config Manager, you'll see Kix Explorer, Kix Performance Analyzer, PD tools like File Manager, Fault Analyzer, and quite a number of others that all have their plugins on the ZOS Explorer download site. You just tick the ones you want. Obviously, you have to have the corresponding mainframe product on the back end, and then you will get those plugins downloaded, installed, and running in the ZOS Explorer for your use. So if you hadn't had a look at ZOS Explorer yet, it might be something useful to do. So what do you do with our Explorer plugin? So you can use it largely to look from a single point of view, have a look at all your different IMS systems and how they're configured. Not only the startup parameters, but the resource definitions as well. You can compare across multiple systems. There's a lot of analysis you can do using filtering capabilities. There's a fully functional Type 2 command interface that you can use as well. It's as an alternative to the TSO SPOC. And you can export the data if you want to CSVs for loading to Excel if that's something you want to do. So as you see at the top, we have the ZOS Explorer that obviously gets installed onto your desktop along with the plugins. We see our Common Services Library server running on each Plex. And then each of those servers is then having a look at the different definition repositories, but also connecting to CSL to issue Type 2 commands. Okay, so in this particular example, we can see all of the information from our definitions repository, the IMS Connect systems that we have, the IMSplexes. If we expand the trees, we can see all the systems that are inside those plexes. There's a tree to expand. You have all the IMS systems, but in this particular example, we've said we want all sources. So we want all of the plexes, all of the IMS systems, all of the IMS subsystems, all together. And we're going to have a look at a member list. So we're saying, okay, the different plexes, what system it is, what type of system, the member name, the proc line, the library number, all the ISPF statistics, etc. Over on the right-hand side, we see something called message. So if we've actually picked up any kind of syntax error or problem with a member, that will show in the message field. Now, one of the things about IMS and the proc line members, so I guess it's a little unfortunate that they have all developed over time, and each development group that has used a proc line member have not been consistent in the syntax and the rules for coding that member. In particular, some of the rules for having parameters that appear more than once. A lot of the proc line members actually will not give you an error if you specify the same parameter more than once. Some of them will use it the first occurrence, some of them will use the last occurrence, and there's no consistency for that either. And when we ran this at one particular customer, they were very surprised to see a whole lot of error messages coming up against some of their members that hadn't been changed for quite some time. And when they looked into it, they found that they had obviously started off with something on one system, put it in duplicate parameters, and that had just propagated to all of their systems. So they had all of these members with duplicate parameters that they didn't know about, just waiting for just a sort of an accident waiting to happen, because the next thing would happen, they would have to make a change, not knowing there's two occurrences, change one of them, and inevitably it would have been the wrong one, and that would have caused hey, why didn't my change take place? And it could have caused some issues. There's some very powerful capabilities in this user interface. Obviously, the standard sort of thing that you expect to be able to do. You can sort on the different columns. You can move the columns around. You can change the width, all of that sort of thing. But there's also a comparator, and we'll see how we can use that in a couple of screens. I haven't got anything to show you the summarization capabilities. We'll have a look at the filtering capabilities as well. You can actually just save the list that you generate. So I could say, let me save a list today of what my system looks like, and I'll come along in 2 weeks' time and I'll create a new list and then compare, and you can have a look what's changed. Or you can export to CSV before loading up into Excel. So now we've gone from that list. There's a couple of things that you can do. We can have a look at let's have a look at the configuration of this particular member. So one of the things about the way we display the values, it's obviously all tabular. We're looking in this case at the DFS-DF member, and if we just taken the whole contents of the DFS-DF member and just so that everyone who isn't familiar with it, the DFS-DF member has a number of different sections, and each section has a large number of parameters, and we could have just put one huge long row that would have been very difficult to work with. So what we've done is actually say, well, we actually can break it down by the sections, and you can see, okay, you can select a particular section to work with, and then all the values will come up for that particular section. Obviously, this is an IMS version 15 system that has the new logger section. Sorry. And then we can see over here all the different values that in the logger section for the particular IMS system. We can also have a look at the source. We'll say view source, and it'll take us into the source for the member. Any syntax errors in that member again will be highlighted exactly as they were with the ISPF dialog. So that same syntax checking takes place in the GUI as does in the dialog. There is no update capability in the GUI today, but that's something we're having a look at adding. Okay, so the comparator now, and I'll explain the meaning of this in effect in a minute. But what we're looking at here is a number of IMS systems and a number of plexes, and we're looking at their DFS PV startup member and all of the values that pertain to that member. And we've actually done a compare across the members and come up with this what we call a heat map. So the way the heat map works is that every time you get a change in value, the line or the cell before and the cell after the change both get highlighted. So it very quickly shows you all the different areas where changes have occurred. We can see obviously in this Apple ID column here, there's lots of changes, but there's no highlighting. So the comparator is pre-configured to ignore certain columns, and you can change the configuration. So well, actually, in my system, I'm not too concerned about ARC. They can be different from one system to the other, so I'll just turn off highlighting for ARC in the comparator, and that will change. That will cause that column not to have any highlighting. Okay, so I said I'd just explain a bit more about what that in effect row means. So in this case, we're having a look at the DFS PB member specifically. When we look at the DFS PB member, we'll get 4 rows. An in effect row that shows us, well, what startup parameters are actually in effect with my running system right now, and then you see all those values going across the right, and then we see underneath that, where did that value actually come from? Did it come from a JCL override, which we see over here? Did it come from the DFS PB member itself, or did it come from the IMS gen? So there are actually a number of different ways that you can specify IMS startup parameters, 3 different ways. We have a look at we have a look at all 3, so we can see where parameters are coming from. And this can be quite useful if you have a parameter that can be specified by the IMS gen as well as via the DFS PB member, and you might want to have a think about, okay, let's put it in the DFS PB member so that when IMS removes it from the IMS gen, which is their long-term objective to get rid of IMS gen, then we'll be prepared for that. We might see things like this over here. We actually have a JCL override of N, but the DFS PB member is already N. So why do we have the JCL override? It's kind of not serving any purpose, and we may as well get rid of it. Okay, now we're let's have a quick look at looking at resources. So previously we were working with a tab called parameters. We're now working with a tab called resources. So select all the databases, and now we get a list of the databases. So we've actually set up a filter in this case. Let's set up this filter so we can look at different values in different colors. So one of the things about the filters, you can use filters to exclude rows, or you can use filters to colorize rows. So you can say for this filter, if this column matches this value, put it in blue, put it in gray, put it in red, whatever you want. So that's this colorization that you're seeing over here for different types of databases showing up in different colors. Probably not something that you'd want to do from in practice, but just a way of illustrating what the capability is there. So now we're using a type 2 command interface. We just do a query IMSplex command, show all, and that's showing us all the members in the plex. The results of a type 2 command and the results of our resources are the same. It's all tabular, and you can use the same comparator, filter, summarizer, etc. on the output of a type 2 command as well. So in this case, here's an example. We've done that. We've set up a filter on the LCL stat column, so we can find anything that is a problem. So PSPs that are not in it get highlighted in yellow. We're having a look at all the different programs across particular IMSplex. You can see the sort of IMS systems down there, and highlighted in yellow those parameters that or those PSPs resources that have a problem. In this example, we're having a look at a number of different IMS systems, and we look at our transaction definitions, and we're picking up differences that there might be. So we can see processing limit count times in this particular case over here, 5,500, 5 million or 50 million. That might be a cause of concern why they're so different. It's just a very quick way then of looking across all your systems, having a look at definitions and seeing if there's any differences between them that might be an issue. Okay, so I hope I've shown you today how using Config Manager you can have better control over your topology, get a better understanding of what's connected to what, very easily see what data sets and PROC Lib members you have for each system, how you can, with a lot of ease and a lot of confidence, actually find the right members, edit them, check them, change them, and if something goes wrong, revert to a previous version, as well as from an enterprise point of view, from a single point, have a look at all of your resources and parameters across your systems, and summarize and compare them for analysis, as well as just use the Type 2 command interface as needed. Okay. So just a couple of links, and as Trevor said, this will be on the website for download after the presentation. That's where you can get the ZOS Explorer, the documentation, as well as the marketplace on the IBM website. Bit more information about IMS tools. I won't go through all that. You can read that yourselves later. And that all takes us to the end of the presentation. And Trevor, if you want to take back control, that is, I am done.
Okay, that's great, brilliant. Thank you very much, David. Does anyone have any questions for David? I'll wait a few seconds, see if anyone's typing in questions. Okay. Ralph Stam says, what will this tool cost?
I'm afraid I'm on the technical side, not on the on the marketing side. So it is value unit price. So depending on the size of your system, and I guess your IBM representative or sales representative should be able to answer that question better than I can.
Okay, and Julius Brosh has said, can this all be added to RDZ and the rational testing tools?
In the same Eclipse shell, it certainly can, yes.
Okay, and Karen Tischer says, love it, thanks.
Thanks, Karen.
Have you got any more? Or should we move on? Okay, if anyone has got any questions, they can always send them to me, and I'll pass them on to David, and he'll respond to you. Okay, let's do that then. Let's move on. Let's take back control. There we are. Brilliant. Right, thank you very much, David. Because we're the virtual IMS user group, can you assume that we're giving you a virtual round of applause then for your presentation? So thank you very much.
I'll take a virtual bow, thank you.
Great stuff. Okay, moving on, we actually have some news since we last met. CompuWare has updated Topaz for Total Test, which is its automated mainframe unit testing software. The product now provides automated unit testing for IMS batch and transactional applications. If you want to find out more, there's a link to the press release on our website. As for articles, well, Sandy Sherrill has been on Z Systems developer community and put up something about happy 50th anniversary IMS. And again, the link to that is on our website. Almost lastly, can I ask for feedback about this meeting? Again, you can email your comments to me. The address is on screen, or you can use the Contact Us webpage on our website. So, what's coming soon then? As you can see, our next meeting will be on the 9th of October, when Rosemary Galvin, IMS Tool Solution Advisor with Rocket Software, will be asking you to rethink the way you manage IMS. And after that, the next meeting is on the 4th of December, when we've got IBM's Susie Wendler to present. The actual title we'll put up on the website shortly. And good old social media. Can I remind you that you can keep up to date with what's happening in the world of IMS and on the Virtual IMS User Group website by following us on Facebook and Twitter. And you can also join the Virtual IMS group on LinkedIn. And the URLs are all on the homepage of our website. Everyone likes on social media, so if you can like us on Facebook, and if you are a tweeter or an Instagrammer or even a Facebooker now, you can use the hashtag VirtualIMS. Okay, well that's all for this meeting of the Virtual IMS User Group. Can I thank you all for attending? I must thank Fundy Software for sponsoring this user group. And I'd particularly like to thank David Mierowsky for today's presentation. So that's it. Thank you all very much for joining us. And I look forward to seeing you in 4 weeks' time on the 9th of October. So thank you all very much and goodbye.